Hi guys! So this is my video to go over that least common multiple live class practice. This is mostly for my first period because I'm just going to apologize ahead of time. I don't know what happened. Okay, so I'm just going to do better and I'm going to show you that I can teach you this. Okay, so one of these examples in here we're really struggling with, and so we're going to talk about least common multiple when we have multiple numbers. We're still going to use that ladder method, but there's a little bit more to it. Not really. I'll show you. So let me get back here. All right, so let's say that I want to find, let me go back here, 4, 6, and 8. All right, so if I want to find the least common multiple of 4, 6, and 8, we're still going to use the ladder method. That's not going to change. But the thing here, in order to completely start doing the L, we have to make sure everything outside of this L is a prime number. All right, so we have to make sure everything outside of the L is a prime. Right now, none of these are prime. But so what we're going to focus on is pulling out prime numbers, and eventually we'll get down to the bottom where there will be only prime numbers left. So in here, so let's pull out the number 2. I know that they're all even numbers. I can see that. So 4 divided by 2 is 2. 6 divided by 2 is 3. And 8 divided by 2 is 4. All right, so now we're going to look at these numbers, and we have to make sure they're all prime. Well, they are not all prime. So that means I have to pull out another prime factor. I'm not necessarily looking for a prime factor that goes into all 3. That's not necessarily what I'm doing here. What I'm trying to do is I'm trying to get all of these prime using the ladder method. So in this case scenario, right, the 3 is already prime. There's nothing that they share with 3, but 4 and 2 share something. So I'm just going to carry down this 3. He just kind of gets carried down. He's still on the next level. But for these two, I can pull out a 2. So 3 is going to be carried down, but for 2 and 4, I can pull out the prime of 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. Now that we're down at the bottom, there are no 2 that share the same prime factor, so there's nothing that I can pull between all 3. So just like in LCM, we want to go ahead and we multiply the L here. So when we multiply all of these numbers, so if you do 2 times 2 times 1 times 3 times 2, you should get 24. And that should be your LCM. So sorry. The other ones in this case scenario will work just fine. You just want to make sure that you bring them all down to primes. I don't know what happened here. So I'm going to do some of these word problems in this video that we never really got to, and so I want to make sure I'm doing them right. So the thing about least common multiple in this situation is it doesn't tell you anywhere that you are doing least common multiple. So that's kind of the one thing that might alert you. I'm not sure what to do. And I think with word problems, that's the most difficult part, is figuring out what you need to do. So in this case, let me show you some keywords that you can see. So we are talking about an auditorium and they're lining people up. Every student whose seat is a multiple of 4 gets chocolate, a multiple of 7 gets jelly beans, and a multiple of 10 gets chips. So, but if eventually there will be a person that will get all 3, which is crazy. We just have to figure out what that person is. So in this case scenario, we have to figure out when do all of these multiples come together. So keywords that you'll see in here are multiple of. You'll see all, like the word like when would they get all 3 together, things like that. So those are keywords to let you know, oh, I'm trying to find the least common multiple of 4, 7, and 10. So we're going to come back here. So I'm going to find the least common multiple of 4, 7, and 10. Now again, our goal is to get them all prime. In this case, we only have one prime number. But these two are not prime. So we've got to see, do they share a common factor? They sure do. They share 2. Okay, I'm going to bring down the 7 because he's already prime. 4 divided by 2 is 2. 10 divided by 2 is 5. So now when I look at this, I have to decide, like, do they share common factors? They just so happen to all be prime. So this is when I'm going to multiply all these numbers together. This is when you do the L in least common multiple. So we're going to do 2 times 2 times 7 times 5. And you should get 140. So what that means is that if you are the 140th person in line, you're getting all 3 snacks because it just so happens to fall that way. All right, let's go to the next one. So we can tell we're doing least common multiple for all of them. In this case, let's look at some keywords. A zoo is running a promotion which every 30th person through the gate receives a free tote bag. So that means the 30th person is getting one, the 60th, the 90th, the 120th, like they are all getting it. The 80th person receives a free pass. So that means if you're number 80, 160, 240, like those people are getting the free pass. Eventually, someone will get both, right? So eventually someone's going to get both. Now these numbers, you can list out the prime, you can go ahead and list out the multiples if you'd like to. That's perfectly fine. I'm going to show you how to do it using the ladder method. And that, or you can just list out the multiples of 30 and the multiples of 80 and see when they match. All right, so let's do 30 and 80. So I'm going to find the LCM of 30 and 80. So I'm going to pull out a 5 because when I see zeros, I'm like, oh, 5. Okay. So 30 divided by 5 is 6. So sorry, I'm writing. 30 divided by 5 is 6, and 80 divided by 5 is 16. All right, so they're both even numbers. I can actually pull out a 2. That's a prime number. 6 divided by 2 is 3. 16 divided by 2 is 8. Now, we're here. They don't share a common factor, prime factor anymore, but they're still not both prime. So this is kind of the extension to that ladder. We still have to get them prime. So 8's my issue, but 3 is good. So 3 can come down But I'm going to pull a 2 out of 8 and get 4. I'm still not done though. Because 4 is still not prime. I have to do this again. 3 is coming down again. And I can pull another 2 out. So now, this is a really big L. Now, if we did least common multiple here, now this seems like the longer way to go, for sure. And sometimes the ladder method isn't the easy or the better option. So you should get 240, but which is fine. Sometimes it's not the better option. If you're like, this is so confusing, you can absolutely just list the multiples of 30. Come down here a little bit. So you could do 30, 60, 90, 120, 180, 210, 240. And then we can do 80, which is 80, 160, 240. And then you can see them, that's where that first multiple will match up as well. So if this is faster for you, if you're more comfortable doing it this way, that's great. You don't always have to use the ladder method to find the LCM. It is just a method that we've been using in the past to go. All right, last 2. These are so much faster. So Dakota's running a half marathon every 6 weeks, and Madison runs a half marathon every 15 weeks. If they start now, how many weeks will they go at the same time? So when you see the word every 6 weeks or every 15 weeks, it's kind of a key that we're doing multiples. So we're going to try to find the multiple, the common multiple of both 6 and 15. And this one's actually nice and simple. They both share a 3. 6 divided by 3 is 2. 15 divided by 3 is 5. And they're both prime already. We only had to do one quick little step. So there's your L that you would multiply for least common multiple, and you should get 30. All right, last one. Hot dogs come into a package of 10 and buns come to a package of 8, which this is a true statement, and this no one ever understands. If an equal number of hot dog buns are wanted for a picnic, what is the minimum number you can be purchased? Okay, so we are trying to find the LCM of 10 and 8. All right, so we know there's 2 that goes into both. So we have 5 and 4. Now, 5 is prime. Beautiful. 4 is not. So we're going to do another ladder. We can bring the 5 down. He's good to go. We don't have to bother with him anymore. But the 4, I need to take a prime number out. So I'm going to take out a 2 and leave a 2. And then this should be your L. So you'll do 2 times 2 times 5 times 2. So if we did that, 40. So let's go back to the problem. So what's the minimum number that each? So you have to purchase 40 of each in order to make it all match up. Crazy, right? Well, thank you so much for watching this video. I, again, apologize to my first period. I appreciate your patience, and I hope this was helpful.